Hello, my name is Bhavesh and I am from India. I am applying for the project Implementation of Computer Vision Algorithms or for Edge Computing or FPGA under Professor Lam's UK. I am studying in the college VJTI, which is located in Mumbai, India. I am in my third year of engineering and I am pursuing electronics engineering. At VJTI, I am a part of this very cool club, Society of Robotics and Automation. Here, we explore various domains such as computer architecture, semiconductor design, computer vision, robotics, and reinforcement learning, etc. One such projects that I made here was implementing convolution in FPGA. What you see here are the simulation results of the project. So basically, I took an image, I applied a filter on it, and then I got some results. I implemented this project using Xilinx's Vivado software and implemented and flashed it onto this very beautiful device, the Xilinx's Kriya KV260. Now, I'll be explaining the working of this project. Okay, so now I'm going to explain you the overall working of my project. First of all, we start with the 128 by 128 image matrix. Then we convert it to grayscale image values. You might ask, why are we using 128 by 128 image matrix? Well, I used it just for the convenience of the project. We can of course scale it to 4K or even 1024 by 1024 image matrix. Then we take the first three rows of this matrix. Okay, this is the important part. We take the first three rows of this matrix, get a 128 by 3 row buffer. Then we take the first 3 by 3 matrix out of the 3 row buffer. We pick out one 3 by 3 matrix and then we convolute it with the filter that the user supplies. Then once we get the pixelated value, we store it in the output. Then we move on to the next 3 by 3 matrix. Then again, we repeat the same process. Once we are done with this 3 by 3 row, 128 by 3 row buffer, we go on to the next row buffer. In this way, we cover the whole image. And we get finally a 126 by 126 output matrix. One improvement in this project is that we can divide the 128 by 128 matrix into 4 64 by 64 matrices and then perform four such pipeline operations at the same time. This will increase the speed massively and it will be helpful in edge AI computing applications. For example, if you were to design a chip which could handle CNN operations, then this overall architecture would be helpful. Thank you. Okay, but why summer research internship at NTU? Well, first of all, I'm passionate about research. The kind of research going on in computer architecture in the silicon industry and also implementing machine learning algorithms on silicon on computer architecture has always fascinated me. The silicon industry has always fascinated me and that is why I got into electronics. I'm pursuing electronics engineering currently. I have explored FPGAs, I've explored ASIC implementation, and one thing I know that I want to keep going on in this field. Coming and doing research on a world-class university such as NTU is a very prestigious activity, and that's why I've applied for this program. Under the guidance of the great Professor Lam's UK, I definitely know that I will reach heights and I will learn a lot of knowledge. In NTU, I know that I will get world-class facilities and faculties and a very good network. That is one of the motivators for me to apply for this program. I really hope that the respected faculties select me for this program. Thank you for your time and thank you for your consideration. I hope I was worth your time.